Hey guys, how's it going? This is Siri, and in this video we're going to be going through an introduction to quantum computing. It's going to be a very gentle introduction. We're mainly going to look at some applications of quantum computing and why we sort of need quantum computing and what problems it can solve. Okay, so what are some of the problems in our world today? Like a big one that has a lot of potential to solve using quantum computing is climate change. Okay, so climate change is a real big problem, as we all know, right? And quantum computing definitely has potential in this area, right? What if we can sort of improve and optimize our industrial production and transportation and some energy grid infrastructure, right? That we sort of have space for that for quantum computing, and it can really improve things. And also, something that's really relevant right now is vaccine development. So vaccine development, right? COVID and all, and some other things coming out right now. Vaccines are very important, and we'll actually go through an example of how quantum computing can actually help with vaccine development. And also, so things that a couple of these problems, right? Only two, I wrote down only two here, but there are many other problems that we can solve using quantum computing. One of which being we can prevent mass blackouts if we sort of improve the energy grid infrastructure. So power, renewable sources of energy, renewable sources of energy, right? So literally any problem. I only wrote down three, but literally any industry, literally any field, right? Just like how data science and artificial intelligence can sort of utilize that data and make sense of it and sort of predict, right? Quantum computing also, can use the massive amounts of data that we have and sort of solve problems. Okay, and the thing that's in common with all of these problems is that we have an insane amount of data. Okay, and the problem right now is that actually we have so much data that even the most powerful computers today cannot solve the problem, or it'll take a ridiculous amount of time to solve it. Okay, and so there are some problems with classical computing, which we'll get into, that quantum computing can solve using and applying laws of quantum mechanics. Okay, so the need for computational resources is really high and really big right now. And so, as I listed, there are a couple of problems with classical computing and classical computers. And so now we have quantum computers. Well, we're still developing them, right? This field is still very a new one, and there's a lot of research going on right now, but it's still very new, right? So quantum computing sort of uses, like I said, quantum mechanics, right? Quantum physics uses these concepts in a lot of algorithms, and those algorithms are better suited for the problems that we have today in our world right now. And not only is it faster, right? Not only do we have this advantage that it's faster, right? But it also solves the problem in a completely different and unique way, because we're using quantum mechanics. So the way that it solves a problem So like the problem solving strategy, you can say, is completely different. Okay? And we're not going to get into all of those right now, right? We're going to get into those in future videos, like superposition, entanglement, and things like that. But the problem-solving strategy and approach is very different, and that's the reason why it's better suited for some problems than others. And there are three ways in which they're different, right? The way in which they compute do the computations, right? How they do the computations, right? What kinds of problems are they good at? And like how fast it is, right? It's like the speed. Okay, and so I don't think that we're gonna get into these three. I think I'll do a separate video on each of these three things. But this is just like sort of like an intro, like some applications. Actually, let's look at the vaccine development application, and so why we might need quantum computing. Okay, so we have like a vaccine, right? We have a vaccine that needs to be developed, and there's a quote actually that, or like a statement that, like, if you figure out, especially like I'm talking about like COVID-19, right? If you figure out the shape of this spike protein, right, then we can figure out how to target the virus. And so the barrier, right, to really fast vaccine development is to find the shape of the protein, right? Find the shape of the protein. And so how do we do that? Well, we do it through simulations, right? And in particular, these are quantum simulations, right? Because we're simulating, really small particles and small proteins, right? So there's like a quantum aspect, basically like quantum simulations. And you do one molecule, like step by step, one molecule at a time, and you figure out the shape of the protein. But with classical computing and with regular computers, classical computers, right, it can take a really long time to figure out what the shape of the protein is, because it's searching through like many options, while through one concept, superposition, it can actually, through quantum computing, we can actually look through multiple solutions at once. And that's through superposition because, we can have multiple states at the same time, which we will dig into in a future video. But it takes a lot less time, right? And so, which is why it's like early vaccine development, like as in like the early stages of the vaccine development, it's like quantum computing can be very helpful if we figure out a way to use it and a way to employ these algorithms and concepts. Okay, so that's sort of like an example of how it's important and it's useful. And so I think in the next video we'll talk about the real differences between classical and quantum computing, mainly that classical computing is deterministic, while quantum computing is probabilistic, which just means that there's a lot of probability involved in quantum computing, and that you don't have a direct answer right away and a definite answer to a particular measurement. But yeah, we'll get into that in the next video. I think that's it for now. We covered some applications, we saw some benefits, right? And this is basically what we'll talk about next time here. Okay. All right. Yeah, I think that's it for now. Thank you for watching, and I'll see you guys next time. Bye.